All right, so we're going to take a look at an example of the calculations that you'll be doing for the stoichiometry lab that you did this previous week. So in the experiment, the reaction that you performed was that you made a copper 2 chloride dihydrate solution by mixing together you weighed out between 2.3 and 2.4 grams of the solid copper chloride, and you added some water to it to make it aqueous. We reacted that with some aluminum foil, which was a solid, and then we ended up making, with the help of hydrochloric acid catalyst, we ended up making aluminum chloride, AlCl3, together with some water. And then the important thing that we made was solid copper. All right, so that's your equation that you carried out, or that you performed, the reaction that you performed in lab. And then, obviously with any chemical equation, before you use it, you want to make sure that it's balanced. And when you balance it, you'll see that we end up with 3 of the copper chloride. That'll give us 3 of the coppers down here. We have 6 waters. We also have, let's see, that'll be 2 aluminum chlorides, and we have 2 aluminums. All right, so the important thing from this equation is the fact that we've balanced it, and we have these coefficients that are going to give us a ratio of one thing to every other thing in that equation. So when you carried out this process, you were able to generate your copper product, right? In the lab, you made this, and then you isolated it, you washed it in the funnel, you isolated it in the filter funnel, you washed it in that Buchner funnel, and then we cleaned it, then we dried it, and then we allowed it to cool, and then we weighed it. All right, so that the weight, or the mass of the copper that you collected, so the mass collected is known as your experimental yield. Okay, and I think overall people were getting around 0.8 grams or thereabout of the solid copper, the brown stuff at the end. So what we can do is we can compare that amount that you collected. So this can be compared to the mass of copper that should have been produced, and that mass is known as the theoretical yield. Okay, and we can calculate that theoretical yield. Okay, this can be calculated through stoichiometry, right, which is the whole idea behind the lab. So what we're going to start with is the mass of the copper chloride, the blue greenish stuff that you weighed out at the beginning. So we're going to get the mass of the copper chloride dihydrate. And that's going to be our starting point. All right, so overall what we're going to do is we're going to take the mass of the CuCl2.2H2O. We are then going to convert that into moles of CuCl2.2H2O. And the reason why we want to do that is because your equation gives you a mole to mole ratio. All right, and the two things that we are concerned with is the copper chloride that we measured out and the copper that we made at the end, right? That's the important thing So we eventually need to get to copper, starting with the copper chloride. So once we convert our mass to moles of copper chloride, then using our mole to mole ratio, we can convert that to moles of copper. And then once we get to moles of copper, we can then convert that to the mass of copper. All right, and each of these steps involves a conversion factor. To get from mass of copper chloride to moles of copper chloride, we're going to use the molar mass of CuCl2.2H2O. To get from moles of copper chloride to moles of copper, we're going to use the mole to mole ratio from the balanced equation. And then finally, to get from moles of copper to mass of copper, we're going to use the molar mass of copper. All right, so if we take this pathway here, we can go ahead and set it up. So I'm just going to make up a number for the mass of copper that we used. So for example, if you measured out, and your number may vary, if you started out with, let's say you used, I'm just going to use a very different number than what you have. So let's say we use 3.21 grams of CuCl2.2H2O. All right, that's your starting point. Your number should be somewhere between 2.3 and 2.4 grams. So that's what we're going to start with. So we have 3.21 grams of CuCl2.2H2O. Okay, our first step is to use the molar mass of the copper chloride. So the molar mass here would be, we just add up the individual molar masses. So we have 1 copper, we have 2 chlorines, we have 2 times 2, 4 H's, and we have 2 times 1, we have 2 oxygens. All right, and then that's going to give you whatever. I'm not going to do that for you. I think you can probably handle that on your own. So you multiply them, you add them all together, and that's going to give you your molar mass. So that tells you, right, the mass of 1 mole of CuCl2.2H2O is whatever number you get when you add all of this together. Let's say we get X grams. All right, I'm just going to put X down here. X grams of CuCl2.2H2O. So the grams of the copper chloride, those cancel. And we have moles of copper chloride as our unit. Then we're going to use the mole to mole ratio from the balanced equation. And when we look at the equation, this tells us that 3 moles of copper chloride produces 3 moles of copper. All right, so 3 moles of CuCl2.2H2O is equal to 3 moles of copper. So I'm going to take that and use that as my conversion factor now. If I want to end up with moles of copper, all right, I'll put the 3 moles of copper on top. And then that's for every 3 moles of the copper chloride underneath. So the moles of the copper chloride goes away. And then if you notice here, the 3 and the 3 also cancel, so that just ends up being 1. And the last step would be to use the molar mass of copper, and you can get that from the periodic table. All right, whatever that is. Let's say this is Y grams. And we use that as a conversion factor. For every 1 mole of copper, we have Y grams of Cu. So the moles of copper then can cancel. All right, so we end up here, the only unit left is the grams of copper. All right, and you're going to get a number. Let's say this ends up being Z. And this mass that you calculate here at the end, due to stoichiometry, that is known as your theoretical yield. Okay, and you get that from the calculation, from the stoichiometry calculation. And then we can compare that. We can compare your theoretical yield with the actual amount that you obtained, which was the experimental yield, right? To see how well you actually did the experiment. So let's say, for example, you collected, let's say 0.79 grams of copper. That's your experimental yield. And then through the calculation, the stoichiometry, you determine that you should have calculated, or you should have collected, sorry. Let's say this ends up being 0.95 grams of Cu. All right, so this here will be your theoretical yield. So then the last thing you do in your calculations is we're going to compare, we're going to calculate something known as the percent yield, and that is equal to the experimental divided by the theoretical times 100, right? The experimental is how much you collected in the lab. The theoretical is how much you calculated through the stoichiometry, and we simply plug those numbers in. All right, so we said, for example, that our experimental was 0.79 and our theoretical was 0.95. And that's times 100, grams cancel. All right, so you plug that in to your into your calculator, and you end up with 83% yield. Right, so that means you collected 83% of the amount that you should have gotten when you did the experiment. All right, so those are the steps involved in the stoichiometry lab calculation.